I apologize for the clickbait. I know you clicked over because you saw the thumbnail of the Baltic birch plywood and just had to click to find out what's that all about. Baltic birch is arguably the sexiest of the engineered plywoods. So I can't blame you. So this is the current state of my build as of the making of this video. So I didn't design this machine. I got this from Woodsmith magazine, and you can go there to woodsmith.com and get the plans if you want to follow along or build it yourself. I'm not going to show any of the plans here because of the copyright, but I'll tell you what I'm building as I go along. And I do make some modifications, some substitutions, and I'll talk about the reasoning behind the substitutions and changes as I go along. So, alright, let's get it on. Alright, for this machine, everything's pretty much made out of 3/4 inch Baltic birch or equivalent plywood. My Baltic birch came in at just over 11/16, so keep that in mind when you're taking your measurements and adjust the plans accordingly for your case. So I cut out all the pieces, I piloted all the holes, and I actually countersank them too, but not necessary if you're using spacks or similar screws that dig their way in. So once I had all the pieces dry fit, I glued, screwed, and tattooed everything together, and then slapped a coat of shellac on it just for some protection. The next step was to give it a nice set of legs, and I enjoyed this part. I am a leg man. And this is a picture I found on my camera while I was making the video, and it kind of spooked me because if you look really close you can make out a figure. So the next step was to build the x-axis ways, and they're made of 2 pieces of plywood glued together and then cut 45s all around to able to accommodate the inch by inch aluminum angle that makes up the surface for the ways. You can see here a side profile of what I'm talking about, and I'm a little dubious of this going into it. No kitty, it's my CNC. Go away, kitty. Anyway, I'm a little dubious of the aluminum angle holding up over time, but we'll see. Some people online have said that it's holding up just fine for them, so but I'm just worried that this V-channel groove bearing here is, hard steel, and that's going to dig into the aluminum over time, but we'll see. So once the ways were assembled, then the next step was to screw them to the sides. And so I made these spacer blocks that are the same height, distance from the bed on either end, clamped them in place, and secured it on either end. Moved the spacer block to the middle, secured it in the middle, and then put the rest of the screws in to complete the attachment. Did that for both sides. So here's the rails all attached to the bed. So far I'm pretty happy how they turned out. Like I said, I'm kind of worried that they'll wear down over time, and maybe something like a stainless steel would be a better option. Who knows? We'll see how they hold up. Maybe I'll end up replacing them down the road if I really use this machine a lot, which I'm not sure. We'll see. So I forgot to take pictures of the gantry sides as I was putting them together and making them. There are 2 pieces of 3/4 inch plywood for the sides, like one piece being a stiffener, as you can see there, to beef it up, give it some stiffness and support. And then there's a block of just a bunch of 3/4 that is going to be a support for the cross piece. Something important, obviously, is you want these sides to be mirrors of each other, exact mirrors. So what I did is I just nailed the two main upright pieces with some tack nails before I cut out the shapes. That way I knew they would be identical. And you want to make sure, obviously, the holes that line up on the ways are perfect 90 with the front face of the gantry where you can see the level is attached. You want that to be perfectly 90 with the bed. So once you have the gantry sides built, you can attach the V-groove bearings, 4 for each side, with bolts and washers and offset cams to be able to adjust accordingly to get a nice tight fit. The plans called for wood cams. I have a milling machine and a lathe, so I made the cams out of aluminum, and I'll show a picture of those. So here's where the cam goes in the assembly. You can see an exploded view of the parts here. So here's my 4 cams made out of 1-inch aluminum. For the cam knobs, it's a 1/4-inch aluminum plate, and I just cut out that profile. And the way I'm attaching them to the cam shaft is I'm cutting out a sort of a rectangular shape on the ends of those on my CNC metal CNC machine that I have, and then cutting that hole out of the plate and then press fitting them together, and then putting it all back on the mill and machining out the shape of the handle. And here's the finished product. So now we get to turn it over and tickle the undercarriage. So this is the end cap that holds a bearing that the threaded rod goes through for the x-axis motion. And here are the parts for the motor assembly, the block that holds the motor mount, and then a plate that holds everything to the table. So I've got the Acme screw in, the motor attached, the anti-backlash nut with its associated bracket that's going to move the x-axis. So then I attached the 2 gantry sides together with the bottom cross piece and tried it out. Then it was time to flip it back over and work on the gantry cross pieces. So here they are assembled. So I put the framing square up and noticed that one side of the gantry had a slight gap, so there was a bit of a twist. And you know, it probably for this machine wouldn't be a big deal, but I decided to shim it anyway to make it true. So for the shims, I didn't have any shim stock handy, so I cut up a Le Croix sparkling water can, and it must be Le Croix. And now you can see it's nice and square. Or I just held up the square flat to the surface to make it look like it. So that's where she is right now, and the next step is to do, of course, the y-axis assembly and the z-axis assembly, and then for this I'm going to deviate for the z-axis. So I'm going to buy a pre-made z-axis assembly just to save time, and plus I figured the z-axis is probably pretty important because of the stresses that are going to be put on it, due to the fact that I am going with a spindle rather than a router, a compact router. So that should be interesting too. Got a spindle off of eBay and had a lot of issues with it, just trying to work with the seller to get a working one, because they sent me a box full of junk basically. Said it was new and it was a return spindle. Went back and forth with them. I think I have a working spindle now. I'm not sure, but we'll find out. So that's my plan for the power of this beast. And for the controls, I'm not going to go with their suggestion. I am going to use a Centroid CNC unit called Acorn CNC, which is a pretty slick little unit. I use the Centroid CNC control system for my Bridgeport CNC knee mill. So I can talk about that in another video too, but so that'll be the next coming videos. I hope you return. Hope you enjoyed this video. If not, that's okay. You can't win them all. But please like and subscribe. I plan on building lots of interesting projects. I have a few currently filming between the honeydew list and my own crazy ideas. I have a lot of things going on, so please come back, check it out. Appreciate it. And I do sincerely apologize for the jump scare.